Today I'd like to talk about individuals' travel behaviour over multiple days, particularly in transport modelling and in data collection. We've kind of traditionally assumed that people do the exact same thing every day. Things are very repetitious. We don't have people doing random new adventures every day. You know, all of our weekdays are exactly the same. But particularly with the developments in ICT, this assumption is getting increasingly questionable, really. And it really matters, because even if at the aggregate level demand seems pretty stable from day to day, if it's not the same people making the same trip every day, it makes a difference. It makes a difference to our understanding of traveller needs and what kind of transport systems and transport services we develop for them. It makes a difference to the fare structures that we want to design for them. Weekly and monthly tickets, depends how frequently they travel, where they're going and when. And it also matters if we're going to be modelling things like network disruption or looking at other types of changes like changes in working patterns and thinking about the kind of impact that would have on transport. Thinking about travel over multiple days and day-to-day variability really matters. And this is one of the areas where I think the types of data we've been talking about today is really, really valuable. Because we're talking about being able to collect lots of data about lots of people over longer periods of time. So I think for this particular area of research, this type of data is really, really valuable. So I'd like to talk briefly about one piece of research that I've done using Bluetooth data. So Bluetooth is a wireless communications technology. It's in smartphones, laptops, also hands-free kits, and it's in a lot of vehicles within their audio systems. And the special thing about it is that each device has a unique identifier. And when one device talks to another device, it tells it its name, this unique identifier, a MAC address. So this is really useful for transport research. And a lot of cities have ended up putting up these boxes you can see here, which scan continuously for these MAC addresses, because they're unique identifiers. So you can scan it in one place on the next to the road network, you can scan at the other end of the link, and then you can actually match up those unique identifiers and get travel times. And these boxes are really cheap to implement. So for example, in Greater Manchester, they've installed over 500 of these next to the road network across the region. And it's been a really cheap way for them to be able to estimate travel times on the network. But because these unique identifiers, they're always the same for devices, subject to asterisks and potential complications, which if you want to talk to me about afterwards, you can. This can actually be used to match people between days as well. So this was one piece of work that I did. I just used 23 of these sensor locations around the town of Wigan in the northwest, and I used 1 year of data. So I wanted to see if I could identify different segments of the road-using population based on the frequency of their trips and the spatial and time of day variability in their behaviour, in these people's behaviour. I haven't got time to talk about the actual findings. I really wanted to talk about the process today. It was really challenging to actually process this data. Not necessarily because of the volume of the data, even though there was a lot of it there. What was really challenging with the processing was the assumptions that needed to be made in order to clean the data. Now, I was really lucky in this type of data in that the boxes, the local authority actually get the raw data from it. So I could look at what different assumptions I made and what impact that had on the data. But I know with a lot of the data sources that we get, you know, that's not the case. You're getting data that's already been through this process by somebody else using some rules that you don't know about and can't change. So in that sense, I was really lucky. So one of the other challenges then came in terms of the analysis, particularly looking at the time of day data. Because it gives such precision in the times of day of observations. It's just so different from other kinds of data we get, you know, from travel diaries and this kind of thing. So looking at the literature where traditionally data might have been, put into hourly bins, for example, it's like we need to think out of the box when we've got this kind of data, to say how can we really take advantage of the benefits of this data and come up with new methods to take advantage of that time of day granularity. So for example, in this case, I used model-based clustering, did some estimated a Gaussian mixture distribution for each individual traveller separately. So then I could identify different components in their daily routines. I say daily routines, it's not necessarily things that they do every day, but things that they do during a day at some point during the year. So to kind of try and kind of understand the traveller behaviour a bit more. And for the spatial variability, it was even more complicated because Bluetooth devices aren't guaranteed to be detected by a sensor when it passes it. So you can see here, perhaps on the ground, one trip through the network could be recorded in lots of different ways based on the sensors it's actually observed at, because it could be missed at various places along the way. So you have to do quite a bit of dimensionality reduction to actually get this into a format which is sensible, because you don't want to be comparing two trips that look different in terms of the sensors it was observed at, but actually is the same trip and underneath it. So I developed a method actually using sequence alignment that was originally used for comparing protein sequences. So this was used to compare the similarity of these trip sequences that were observed in the data, and then being able to group them into similar trips so I could measure spatial variability for each of the groups. I've gone through that quickly, not because I'm sure you're all going to go, all right, I'll go and apply that particular technique. But the main point to make is that there are different things we can do with these new types of data. And whenever I do presentations, I get questions about, can I estimate this particular parameter for these models we already have? And to an extent, we have to kind of be amenable to that in terms of working with practitioners who perhaps use these models. But I think when we see these new types of data, we need to be thinking, what new insights can we gain, for example, about travellers from these data sets? And quite often that's going to mean developing new methods. And I think the methods is really the key here, because technologies are going to come and go. But when we're talking about mobility, there are certain types of data we can have, and the technologies are going to change, and we're going to need to adapt the methods based on the specific type of data. But I think there's going to be a lot of transferability of the types of methods that we're now developing for these new types of data. And to also say, I think it's been said by a few other people here, there's no perfect source of data. All we can do is see, what's the quality, what's the disadvantage of the data we have got, what can we do with it, what is this particular data source good for, and how do we use different types of data sources together to gain an overall view. No data source is going to tell you everything, but can we bring things together to gain better insights?